Now your calculator is your best friend in this course. All right, that you might have heard that in previous courses, but it wasn't as true as it will be in this course. All right. If you don't have a calculator, or on any given day you forgot your calculator, you don't have to ask me. Bottom drawer right here is where I keep the spares. I have a set of 10 calculators. Just come on up and grab it. And just, I only ask you to put it back at the end of the period. All right? So, I generally don't have to worry about this with seniors, but with freshmen, it's more of an issue where they just leave it on their desk. Like I'm supposed to fetch it like an animal. It's like, who do you think I am? So, yeah. Just right back in. Or you can hand it to me and say thank you. Or just hand it to me. Or leave it on your desk and say, fetch, dog. No, don't do that. I will not find that funny. Honestly, I won't find it funny only because I will have forgotten that I talked about it just now. So that's the issue there. Anyway, when it comes to finding limits graphically, there's a couple of ways to handle it. And shockingly, one of those ways doesn't involve creating the graph. All right, so it involves a numerical approach. So when it says find the limit graphically, you might opt to say, okay, but I'm not going to create the graph. All right, so we'll do that second. The first way is the way that we're going to just follow the instructions. It says graph x minus 2 over x squared minus 4. Now, this goes all the way back to Algebra 2, your favorite course. Honestly, Algebra 2 gets a bad rap. No.
I think it depends on the teacher.
Honestly, Algebra 2 is always better the second time around. You know, like pre-calc? So pre-calc, you get a lot of the same stuff in Algebra 2. You know how like in pre-calc, when you were working on some of those Algebra 2 concepts and it all made a little bit more sense? Yeah. You're like, oh, I get it this time around. You're such a great teacher. No, you're seeing something for the second time. It makes more sense. It's like watching an M. Night Shyamalan movie. Like, it didn't make sense the first time around, not because he's a terrible director. I mean, for some movies he is. But it's because the second time you watched it, you were on the lookout for certain things that just made more sense. It had nothing to do with anything else besides that. All right? So, based on past experience, I know x squared minus 4. I got to factor that, right? And my factors are what? X plus 2x minus 2. You know, flashback to Algebra 2. There would have been like a 30-second pause before somebody gave an answer on that one. All right? But it came immediately because you have more experience with it. All right? So you have a common factor, so we're going to wipe that out. Now, we also have to keep in mind that when you cancel a common factor, that manifests itself in the graph in a certain way. All right? But I'm going to write f of x is equal to 1 over x plus 2. All right? From that simplified graph, I get horizontal and vertical asymptotes. What's my vertical asymptote? We'll start with that. X equals negative 2. Now, here we care about the graph. I don't care about as much the surrounding pre-calc work. So if you just wrote VA, vertical asymptote, negative 2, you're not going to lose credit like you would in a pre-calc class because the focus in the pre-calc class was properly identifying the equation of the vertical asymptote. As long as you plot it correctly, I don't have a problem. But it is a vertical line, x equals. So you at least should be aware of that. Horizontal asymptote, y equals 0. How do we know that? Plug it into the calculator, look at the picture. That works. Another way to do it is to look at the powers. Right? If the power is smaller on the top, so the power of x, right? The power of x is 0 on the top because there's no x there. Power of x is 1 on the bottom. Power is smaller on the top than it is on the bottom. That's the rule dictating why the horizontal asymptote is y equals 0. Later on in the unit, we're actually going to learn the origin story for that rule. We're going to learn where that rule came from. And it's kind of strange because we learned that rule so that we could find limits, but we actually need to understand limits in order to see where that rule came from to begin with. All right, so it's kind of a circular logic kind of thing, but it is what it is, as Mr. McCallie would say. So I'm going to put dashed line segments for my asymptotes. Anything out of context, I would really like to know what was going on over there. All right, now there's going to be some graph action associated with this, right? Now, the amount of algebra you do for this is really entirely up to you. I wouldn't do any more algebra, all right? You can figure out the location of the point discontinuity on your own. You know, the common factor that canceled, that corresponds to a hole in the graph. But the calculator is going to point that out for us anyway, so I'm just going to do it that way. All right, so I'm going to take my original function, plug it into y equals, so I got to turn my plot one off. So anyone who's a stat person, just make sure that, well, actually, this goes for anyone. If you have, you see plot 1, 2, and 3, for any function-based math class, so calculus, pre-calc, trig, or anything like that, those should be blank, all right? Because those turn statistical plots on. So if you ever get error dim mismatch, it's because you have a stat graph on, all right? So just make sure that those are blank. So if one of them is highlighted, like this, just go up and hit enter on it to turn it off, and you're fine, all right? So that doesn't apply to everyone, but sometimes you borrow a calculator from somebody, one of mine, you know, it's on, and you want to be able to handle it. Alpha y equals n over d, x minus 2, x squared minus 4, all right? I very rarely just hit the graph key. It's always zoom 6, almost always zoom 6, all right? That's the standard view. There's other ways that will manipulate the windows, but zoom 6 gives us the negative 10 to 10 all around. If you just hit graph, it's just gonna keep whatever the settings were for the last time you used the graph, which might be negative 10 to 10, but it might be something else. If you wanted to go back to the standard zoom, why not select zoom standard? All right, so this is what I got to get on paper, but I know something fishy's going on in this graph, so I'm going to go into my table, second graph, and you'll see I have 2 errors. One at negative 2, that corresponds with the asymptote. One at positive 2. In my graph, I don't see an asymptote, right? So that means that there's a hole. Based off of the trend of the data here, where do you suppose that hole is?
2 and negative 2.
2 comma 1/4, right? Because it's going 1 over 2, 1 over 3, 1 blank, and then 1 over 5. Fill in the blank, right? It's probably 1/4. So we're going to have a hole at 2 comma 1/4. Could have figured it out algebraically, but this course is not an algebra course, so use whatever resources you can short of cheating. And if you're inclined to try to cheat, I have privacy shields in the back. All right, they're little cardboard boxes that you put on the desk and like keep people from peeking at you while you're doing your work. So you can tell I've had cheating issues in the past. So, yeah. But I've also had classes where there's like standing room only. Here it's a much smaller group, so spacing shouldn't be as much of an issue. I found that the people who end up like getting the whole like neck craning issue going on, I feel like they're doing it just out of instinct. In most cases, I feel like people don't go into a classroom being like, I will cheat today. It's just like they're so close to somebody else, and then just human nature takes over, being like, I don't know how to do this one. And then all of a sudden they're like, it's right there. I'm trying not to look. I'm trying to do the right thing here. So I'll help save you from yourself if you think that that's kind of one of those things that you might. I find that most people, they actually volunteer to use a privacy shield because they don't trust themselves. So that's something else. 2 comma 1/4, I'll plot that. Draw a little line, or a line, geez. This is middle school, curve. I know what the general shape of the graph is, so that's just a ballpark kind of thing. All right, gone are the days where you need a picture-perfect point-by-point graph. What you need are the important points and then a curve that generally looks correct. All right, so that's the thing. So we need asymptotes, we need the whole. If there were x-intercepts, I would need those. But that's really it. So now I need to find the limits. So a definition of a limit is the value that y is approaching as x goes to a certain number. All right, so that's something that conceptually you all should have an idea about. But practically speaking, it doesn't always play out that way. All right, because you're like, all right, cool, where is y going as x goes to a particular number? So in this particular question, for part A, it's saying that x is approaching 2 from the left. And then 2 from the right. All right. So I call it the little dude approach. I just put a little dude on my graph. He's a happy little dude. I also break out a highlighter and highlight the vertical representing my point of interest. All right, all the way up and down. I mean, you can put it at the location too, but it's not always going to be a singular location. So I grab the vertical of the point of interest. And then I just start following the path of the little dude, right? So I have the benefit of a pointer. So let me just break out my my lightsaber. So we got the little dude here. He's following the path, right? He's starting on the left. He's working his way towards the right. So he's getting closer and closer to -2. If he were approaching -2, he'd be approaching what? Negative infinity. He'd be going down forever. But he's approaching +2, which means that at some point, now this is completely theoretical, we have to imagine that he's able to arrive at negative infinity and then is magically transported to positive infinity to continue his journey. Yeah, I know. It's tough to wrap your brain around, but I'll get to that in a second. All right? He's continuing his journey. As he's getting closer and closer to the x value of 2, what y value is he getting closer and closer to? 1/4. He's getting closer and closer to the y value at the whole, right? Which happens to be 1/4. All right, so the idea of magic being the answer to a math question doesn't generally sit well with people. But the real explanation, and this is completely theoretical, but it's very important, is that lines are figments of our imagination. Lines don't really exist, right? Lines are just little line segments of the larger curvature. So, like the universe, right? The universe doesn't expand linearly, it expands spherically. Same thing with the galaxy and the solar system. You know, like when you learned about the solar system, it seemed very much like everything was on the same plane. But it's not. Like those planets don't follow around the sun. They have their own orbits, but they don't stay on the same plane. Some are going around this way, some are going around this way, and some are going around this way. All right, everything is spherical. A line segment is just the tiniest subset of a curve. All right, so when I'm looking at this line, this quote unquote line, every time you see the word line, there should be like imaginary air quotes around it, because that line does not exist. Because if you were to extend that line towards infinity, because everything is circular, it would wrap around and then meet up with negative infinity, theoretically. All right, so the magical transport isn't happening. It's just that as this little dude is skiing down, he's getting closer and closer to negative infinity, but when he gets there, he is then at simultaneously positive infinity to continue his journey, because he's completed the loop. All right, so that's really what's happening, but again, it's all theoretical. That's theoretical mathematics. I mean, you don't really get into that until you start exploring higher dimensions. All right, we've only lived in 2 dimensions. I mean, you could kind of visualize 3 dimensions, but then you start getting into 4 and 5 dimensions. You're like, where is this all going? Right? This is all just the tiniest little aspect of real space. All right, so again, the Earth is flat, right? From our perspective, sure, but we know it's not, because we're living on a flat subset of a very, very large sphere. All right, so that's generally how it works. So the little dude goes down, he jumps back up, he's continuing on his journey, and as he's getting closer and closer to 2, the y value is decreasing. It's at 4, it's at 3, it's at 2, it's at 1, it's at 0.5. It's getting closer and closer to 1/4. All right, that's where we're closing in on. We're not going to actually get there. The limit is not about getting to your destination. It's about what your destination would be if you could get there. Essentially what you're aiming for. All right, so if you're on a boat and you want to set course, like a long distance, like you want to take that boat to Portugal. Like, you can't see Portugal, but you can aim your boat in the general direction of it. All right, that's what a limit is talking about. What are you aiming for? The idea is not that you're actually going to get there. What are you aiming for?
So if, like, this is similar to one of the later ones, but if that was to say, what is the value of f of x when x equals, what is that? Where does it become the whole 2?
2.
Would you write
Nada.
not applicable, does not exist, or
Pick one.
either? Okay.
Yeah, it works both ways. All right, so my little dude's on the right-hand side. Little dude standing on the right-hand side. As he's traveling to the left, starting off very, very close to 0, now he's at like point a smidge, and then 0.1, and then 0.12, 0.13, 0.1. Eventually, as he's getting closer and closer, as the x value is decreasing down towards a positive 2, what is the y value increasing towards? 1/4 again. All right, so the limit that involves a limiting constant that doesn't have a sign, a plus or minus, that's asking what is the limit as you approach from the left and from the right, right? So if they agree, it is what it is. So 1/4. If they don't agree, what do we write?
DNE or
DNE, or if you were in Ms. Tong's class, maybe it was LDNE. Is she still an LDNE
Yeah,
person?
that was definitely it.
Yeah, that's fine too. But DNE works. Does not exist. You want to write it out, that's fine. Just the only thing you wouldn't write is no solution. All right. So it says f of c, limit as x approaches c and all that stuff, but then it tells you what c is in each question. So f of 4, limit as x approaches 4 from the left of f of x, then limit as x approaches 4 from the right of f of x, and then the limit as x approaches 4 overall of f of x. All right, the first question's not a calculus question, it's an algebra 1 question. Whenever you're evaluating a function, you're just asking what is y when x is that number. All right, so when x is 4, what's y? 1. All right, that's because there's a solid point there that has a coordinate of 4 comma 1. The y value is 1. Now, when we get to the limits, we're talking little dudes. Little dudes climbing up the mountain. Again, what's he aiming for as he gets closer and closer to the x value of 4? Doesn't have to get there in all cases, but what is he aiming for? What y value? 1. So it turns out, coincidentally, to be the same point as the solid point at that location. Now the little dude's on the right-hand side. You don't have to draw the little dude, but I like doing it, so. All right, he's coming in from the right. As he gets closer and closer to the x value of 4, which happens to be at the location of a vertical asymptote on this side, what y value is he approaching? Infinity. If left and right are the same, if they agree, then that's your limit. It is what it is. If they don't agree, then it's D and E. D to the N to the E.